Cool. Okay. Hey, folks. My name is Eric, and today I'm going to present some ongoing work in collaboration with the UCSD Cog Tools Lab and the Stanford Iliad Lab. So to motivate this work, I want to start with a scenario that might be familiar to some folks in this room. So imagine this young toddler is your child, and they want to help empty the dishwasher. So the question is, what do you expect to happen? So on the next screen, I'm going to show just a really quick snippet of video. But as you watch this, think about what's missing from this child's understanding of the task. It's okay if you don't hear the sound. It's a little grainy, sorry.
Thank you.
Nice. All right. Okay, so what happened there? We can see that success on this task requires some knowledge and skills that this toddler doesn't quite have. In this case, knowing, for example, that each item has a particular place where it belongs. And this is just the silverware, right? So when dealing with plates and bowls, there's additional knowledge about the physical world itself that comes into play, like knowing that dishes need to be stacked or arranged in certain ways to be stable, right? So what this boils down to is that collaborating with others involves evaluating their competence. So putting away dishes with children requires careful attention to what they know and what they're capable of. And with adults, as simple as it is, it relies on a rich set of shared knowledge and expectations. So the question we're interested in is, how do people go about making the kinds of competence evaluations that are necessary for this sort of complex coordination? In other words, what kind of cues from the environment or from people's behavior do we rely on when we're doing this? So first, we know that solving this problem of evaluating the competence of others is really important because it's something we do from a young age. So children as young as 4 or 5 can combine features about people's performance and the task environment to determine who's better at building block towers. And this doesn't stop with children. So we know that adults are capable of making these kind of judgments about others' behavior in increasingly abstract domains like stock performance. And then finally, a growing body of work in human-computer interaction and robotics has shown that the kinds of judgments we make about another human's ability based on their behavior can extend to artificial agents as well. So this work underscores the importance of understanding how people judge the competence of others, but making these judgments in everyday life poses a number of challenges that existing work hasn't fully explained. So first, when we judge another person's competence on the world, it's rarely just a matter of whether they can perform a specific task or not. What we want to know is something about the kind of internal model of the world that they have, and this requires observing them in complex kinds of naturalistic tasks. And then a second part of this calculus is that people's knowledge isn't static, it can change, they learn. So when a friend offers to help unload the dishes, they may not know where things go at first, but you sort of expect them to open a cabinet or two and figure it out, right? So in the work I'm going to present today, we're addressing this question of how people evaluate the competence of those around them when they're collaborating. And we're going to try and build on prior work by addressing both of the issues I just described. So first, that people usually make these judgments in pretty rich embedded contexts, and that they often do so with collaborators that can learn and change over time. So in the first part of the talk, I'm going to walk through the experimental paradigm that we use to explore how people collaborate with partners that are differing in their underlying competence. And then next, we're going to look at how people's behavior in this task incorporates their partner's advice. So when you're collaborating with others in a physical setting, how much does their competence matter, essentially? And then finally, we'll address one of the core questions underlying this work, which is how our judgments of another agent's competence can impact our willingness to trust them. So let's get started. First, I want to present the task that we use to try and understand how people evaluate the competence of agents around them. So here, we're exploring people's judgments of competence in this physical setting. And this is important because it gives us a chance to probe these judgments in a kind of rich, structured environment that people rely on in the real world. So to do this, participants are playing a game in which their task is to place a paddle somewhere on the perimeter of this circle to catch a ball that's launched from another point on the outside of the circle. So they're going to move a little paddle like this based on where they think the ball's going to land. So participants, importantly, are also getting help on this task from a friendly artificial agent who is acting as their partner. So they're paired with the same bot partner for all 96 rounds of the experiment here. So each round is going to begin with the agent providing a kind of recommendation about where to place the paddle. So you can see them thinking about it. And then participants have the chance to either change the agent's suggestion if they weren't happy with it. So you can see here the agent's original suggestion is shown in gray, and that's how participants evaluate how well the agent's suggestion would have done. And then eventually they're going to choose when to launch the ball and see how well they and their agent performed, right? So what we're interested in here is understanding how people judge the competence of their agent partner and how these judgments are factored into their behavior in the task. So building on prior work, we're going to use this intervention behavior to try and assess this. So intuitively, if an agent partner is giving helpful suggestions and participants can recognize this, they should be less likely to modify the agent's suggestions over the course of the experiment. But if their partner is unhelpful, they should be more likely to intervene and make larger interventions. So to understand people's evaluations about their partner, we're going to look at whether or not participants intervened on each trial and how much. So importantly, not all of these agents are alike. So the key question here is, what does competence mean in this task, right? So intuitively, people who are competent at a physical task like darts are both accurate and consistent. In contrast, we often think of low competence in a task like this as being unreliable. So this means you're just as likely to hit the wall as the board. This is what happens when I play darts. So participants are assigned to one of 4 different conditions that are manipulating the ability of their partner. And the way that we're manipulating the agent's competences here is by modifying the variability of their suggestions. So a critical thing to establish with this task is that people aren't depending on the agent's suggestions. So in other words, how well do participants do on the task when their partner's advice isn't that much help? Can they overcome this by intervening? So the unreliable agent condition first is what's going to help us address this. So the unreliable condition, or the unreliable agent rather, is sampling its paddle suggestion on each trial from a distribution around the ball's true landing location that has a high variance. So given the ball's true landing location on each trial, which is the little center of the axis here, the unreliable agent is going to choose a paddle suggestion that's often very far from that location, like the green X. So the variance of this underlying distribution was chosen so that the agent's suggestion would only catch the ball in around 20% of trials. So what this means is that participants need to intervene frequently to perform well in this condition. So for participants paired with a reliable agent, things are much better. So this agent samples its paddle suggestion each trial from a distribution that has a very low variance around the ball's actual landing location. So the exact value here was chosen so that the agent's suggestions would catch the ball on about 20 or 80% of trials, sorry. So this condition gives us a really critical contrast to the previous one, which is when people have a competent partner, how much do they rely on them? Can they recognize that this agent gives good suggestions most of the time? So this reliable and unreliable condition allows us to ask how static ability is affecting people's collaborative behavior in this task. But as we talked about at the beginning, a critical component of competence judgments in these naturalistic settings is that people's ability may change over time. So these remaining 2 agents are allowing us to see how sensitive participants were to these changes. So our improving agent started out performing like the unreliable agent, but by the end of the experiment, its behavior is matching the reliable agent. So specifically, every 12 trials, its accuracy is going to improve by a fixed amount. And then finally, we have a worsening agent, which is identical to the improving agent, but in the opposite direction. So it starts out performing like the reliable agent, but by the end of the experiment, its behavior matches the unreliable agent. So in addition to surfacing the role that changes in ability play in people's collaborative behavior here, these agents raise kind of an interesting puzzle, which is how much do first impressions matter? So even though both agents exhibit the same kind of accuracy over the course of the experiment on average, only the worsening agent starts out showing signs of competence. And what we're going to see later is that these early impressions may play an outsized role in people's intervention behavior. So at this point, we've covered the first challenge here, which is to probe how people collaborate with partners that differ in their underlying competence. What we have is a task where people's artificial agent partners are going to offer advice in this difficult physical reasoning task, and their underlying competence is reflected in the quality of the suggestions they provide. So the first question that we ask is, what do people do with these suggestions, right? So let's turn to this question. When we think about how people might have decided whether to intervene on their partner's suggestion, there's 3 kind of mental models of their partner that they might have had. So the first is a kind of full trust model. And what this comes down to is essentially they might have gone with their partner's advice every time, right? And then the second hypothesis we want to test is sort of an opposite one, which is a no trust model. So maybe people completely ignored their partner's suggestions. And then finally, a third account we want to look at is something in between, where maybe they're integrating both their own guess about where the ball would land and their partner's suggestion when they're deciding whether to intervene or not. So we're going to test these 3 hypotheses in people's intervention behavior. So first, we'll test this full trust model. So if people were going with their partner's suggestions every time, we should see very little intervention behavior across the board. So here we're looking at people's average intervention rates on Y, which is how often they modified their partner's suggestions. And we're going to examine these intervention rates separately for each of our conditions to see whether this full trust account is the best explanation in any of these conditions. So if we see something like this, it means that people are essentially intervening on every trial. And the closer people are to this pattern, the more evidence we have against this full trust model. So what do we see? Across the board, intervention rates are very high here. And these intervention rates are largely reflecting the differences between conditions. So people are intervening most frequently with this unreliable agent, least with the reliable agent, and their intervention behavior is changing dynamically as the improving and the worsening agents change. So what this tells us is that people are intervening in ways that are sensitive to their partner's ability. In other words, they aren't merely trusting their partner the whole time. But another possibility is maybe they didn't trust their partner at all. So maybe their intervention behavior just reflected their best estimate about the ball's landing location without regard for their partner's choice, or advice rather. So to address this kind of no trust model, we're going to look at the distribution of signed human errors here. So the human error is how far each participant's paddle placement was from the ball's ultimate landing location in degrees around the circle. And the sign here is designating whether their error was towards their partner's suggestion or away from it. So here, positive values mean that people's paddle placement erred towards their partner's suggestion, and negative values mean they erred away from it. So if the no trust model were true, what we'd expect to see is a distribution something like this, where errors centered at 0 means that people's errors are just as often towards the agent's suggestion as away from it, and that's consistent with them sort of ignoring the agent. So what we see in our results is these are the kernel density estimates of the distributions for each of our conditions, and we have the average value in each condition on the vertical lines here. And so what stands out here is that there are differences across these conditions, but all of them are significantly positive. So what that tells us is that people's interventions are really anchored to their partner's paddle suggestions. In other words, they weren't just choosing paddle placements based on their own best guess about where the ball would land. So if we return to the original question, we asked how people decide when to intervene and how much. And what we find is that intervention decisions are combining both people's own guesses about where the ball will land as well as their partner's advice. But another question is, how does their judgment of their partner's competence bear on this decision about whether or not to intervene? So the results so far speak to people's trial-by-trial decisions, but they don't address how much people factored in a sense of their partner's general ability, right? So how did people incorporate the agent's past behavior into their decision about whether to intervene on a given trial? So the decision that participants face on each trial is whether to intervene and how much. And our intuition says that if an agent is more competent, and people recognize this, they'll intervene less, right? And if an agent is less competent, this will require more intervention. And this is essentially what we've seen in our results so far. But there's one problem here, which is that this pattern of behavior can be predicted even if people aren't thinking about the competence of their partner at all. So people could recognize that their partner gave a bad suggestion without any additional inference about the agent. And then, as we saw in the previous result, they might offset their own best guess a little bit towards their partners just to be nice. And this could be enough to account for people's behavior. So what we need is a way to assess how much people's intervention behavior reflected the past performance of their partner, independent of the partner's advice on any given trial. So in other words, did people intervene less with a reliable partner and more with an unreliable partner, even when their partner's suggestions were off by the same amount? So to test this, we inserted 8 critical trials in the experiment, one in each block of 12 trials. And in these critical trials, the agent's suggestions were the same distance from the ball's true landing location across all conditions. So what we're predicting is that if people were incorporating the agent's past performance into their intervention decisions, we should see people intervening less with a reliable partner and more with an unreliable partner, even on these critical trials where both partners gave the same suggestion. So we're going to look again at the intervention rate, but this time on critical trials only. And here, the optimal behavior is to intervene every time. The critical trial error was chosen to be close enough to the ball's landing location that it was kind of a reasonable guess, but it wouldn't ultimately catch the ball. So if people were behaving optimally here, we might expect to see something like this. But if participants in the reliable condition, for example, were trusting their partner based on the fact that the agent gave good suggestions on previous trials, then we might expect them to intervene less. So what we're going to see here is these are results. So overall, people are far less likely to intervene on these trials. And critically, how likely they were to intervene is differing across conditions. So people are much more likely to intervene on these critical trials when they're paired with an unreliable agent or one that started out unreliable than when they're coordinating with a reliable agent or one that started out reliable. So we're also going to look at how much people modified the agent's suggestions. This is the magnitude of their interventions, and we can see in our results here that people are intervening more than necessary when they're paired with an agent that gave unreliable advice and less than they should have with an agent that gave consistently good advice. So this is a similar pattern of results. So if we return to our original question here, we want to know how people's intervention behavior is reflecting judgments about their partner's underlying competence. And we're finding that interventions reflected dynamic evaluations of the agent's competence. So in other words, when people intervened, they incorporated the previous behavior of their partner. So in future work, we want to explore this tension a little bit between the fact that people are sensitive to changes in their partner's competence, but they also have an ability to generalize from past behavior and have some stability in those judgments. So that's future work. And with that, I want to thank my co-authors as well as the UCSD Cog Tools Lab. And everybody here for listening. Thank you.